Hello. Today, we'll be using Claude to refactor our code that we've developed in the last one into something that can be used not only for tests, but then also to be used directly on a piece of hardware. Let's get it started. Hello, I'm Ryan Torvik. I'm with Tuliptree Technology, and this is our leaf. Today, we'll be using Claude to, we'll be using, we'll be using VS Code, Claude, and then we'll be using continue.dev, and then we'll be using PlatformIO, and we'll be using an elegoo piece of hardware to actually see this. So what we did last time is we wrote a piece of software, small thing, wrote a little function, and then wrote tests for it and had Claude do all the tests and everything for it, developing the test for it. So then what we're going to do now, so we've got that tested piece of code, so we know that it functions correctly. We're going to move that code out into a library area, and then we're going to create a new main.cpp that interacts with that code, so we can take that code, so we've tested it, and then we'll have the main.cpp will interact directly with the hardware, and then use that functionality. So we'll know that the underlying functionality is tested very well, but then we'll have the kind of like the stuff that interacts with the hardware directly. It'll be a much thinner thing than our original implementation. All right, so let's check it out. All right, so to recap and go back here, so we've got our hardware here. This is our same setup before. We've got our elegoo Uno R3, and then we got power and ground over here, and then we've got a light hooked up, and it's a three-way light, so it's got the red, green, and blue set. So we've got those three set up, and each one has got a little resistor there attached to it. And then we've got a button over here that's then hooked up into pin 3. So the button's hooked to pin 3, and then each one of the colors, the red, green, and blue wires are all hooked up to the appropriate ones in the light. And the program that we've written is that I click the button and that it should go and actually rotate between the different lights. The first implementation of it was just did everything in main.cpp, which didn't let us write any tests for it. So what we did then is we rewrote the entire thing, and then so it made it so it's testable. And now we're going to take that and put it back into the main area so that the main.cpp can use it and can use that functionality without having to do it directly itself. So there's like this test-driven development. We've got our PlatformIO file that we had before, and we've got our test.cpp. And if we go to PlatformIO and we say native test, we got our test, and that's passed. Okay, so that's what we did last time. And now we're going to ask Claude to move the LED flags and handle button press into their own library, so it can be used by both the test.cpp and main.cpp. We'll just take a header file. Okay, I'll create two new files, a header file and an implementation file. Okay, button LED handler, interesting. Okay, I don't want to do that. I don't want to do that. Modify them, here's how you update them. Okay. Test.cpp. Yeah, nope, I don't like this. Let's try that again. Let's say we're going to move LED flags and the handle button press into their own library. I'm going to specify that we're talking about test.cpp. LED controller.h, LED controller.cpp, blue, green. Okay, so then it's just moving that functionality. Here's the updated test file. Setup teardown, pound include, main. Okay, that looks good. Include guards, inline keywords, now the function, update the test file to include new header. Okay, so we're going to apply this. We're going to apply this. And we're going to apply this. Okay, so then, so I want to update the PlatformIO configuration file. All right, so I'm going to say update it so that we can actually build test.cpp. All right, let's see what it says. Okay, native, include, test build source, web dependencies. Maybe we've already got the web dependencies working. I want to create one. Let's see, I wonder if if there's a PlatformIO way to do that. So So I'm going to ask it where the PlatformIO libraries are supposed to go, because I don't think they're supposed to go in the source directory. Oh, this is interesting. Okay, so the standard location is in a lib directory at the root of the project. So we should be putting lib LED controller. Okay, let's create the necessary files. All right, so we'll create library.json, applied, move them. Okay, so we'll put that there, and that's now in an LED controller source. Apply, LED controller.h, handle button press, update the test file to include the new path. Okay, didn't do much. And there's one diff, and we're going to accept that. And then update the PlatformIO. Let's apply this. Advantages to using a lib. It's the standard way. It makes it easier to share your library with others. Better separation of concerns. Automatic handles include paths for libraries in the lib directory. That's great. Then why did you add test build source? Is yes. So if it's automatic, I'm gonna not apply this to the PlatformIO. I'm gonna leave this alone and see what happens. Let's see. LED controller, GitHub, sure. Frameworks, platform, keywords. All right, let's go look over here. So LED up, so there's that. These are still here though. There's nothing included. So I'm actually gonna remove, I'm gonna say to remove the old LED controller code from the main source code directory. Okay, so I'm gonna run this in terminal. Enter, and let's see if those files are there anymore. They are not. Interesting that it, okay. So we'll close, okay. And then now we'll go to PlatformIO and test. Passed? What? Are you sure? Once again, I don't trust this stuff. LED controller.h. So I'm gonna say, I'm gonna say true here and see if it's actually working. Our test is working. That's failed, okay. Well, I'm also concerned that it's gonna, okay, so I'm gonna go here and say false again, so that should pass. But then I'm gonna go to my LED controller.cpp, and then we're gonna run that again. Wow, okay. Expected false was true, so it did fail when I tested that. Wow, that was really simple. All right, cool. And then I'm gonna go over here again and say test it again. Okay, so the test passed. So pretty simple. So all I had to do, well, all I had to do was talk to Claude, but what Claude did was it moved it into its own header file and source file there, and then add a library.json. But I had to specifically tell it, hey, this is PlatformIO to do this. Give it more context, if you will. All right, so now I'm going to go to the main.cpp, and I'm going to say, I'm going to go back to Claude. Okay, update the main.cpp. Okay, so we say handle button press and update the LEDs on these pins after each time the user presses the button. All right, here's the new main.cpp. There's the button pin 3, LED red, green, blue, 9, 10, 11, false, 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 last button state, okay. Because they got a function, okay, update LEDs is a function call there. Set up the pin mode, and then the red LED pin gets set if the green, okay, that matches. Setup is here, input, pull up, output, and then we set them to a known state. Okay, false, false, false. Read the current button state, so we do digital read of the button pin. Okay, it transitions from high to low with the pull-up resistor, delay, do a little debounce, check the button is still pressed, and then update the LEDs, and then reset the button state. Okay, some explanation for what it is, blah, 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 blah. All right, we're gonna go apply that. And I'm gonna say accept all. There we go. And then I'm gonna go over here to our hardware. All right, so plugged our hardware in. All right, and let's see what happens. PlatformIO. Now we're not using native anymore. We're gonna do the Uno, and we're gonna say upload. Uploading success. Okay, ready? Let's try this out. Red, green, blue, off. Red, green, blue, off. Hey, look at that! That's so exciting. So exciting. And there you have it. So we've used Claude using continue.dev. And not only have we written some code for the Arduino that we've got here attached to our system, but we've also done it so that there's tests that verify that the functionality is going to work the way we expect it to work. So, and our kind of our interactions with hardware is very minimal. So we just do that, and then we can go and change that handle button press however we want to do whatever it is we want to the pins or the LEDs or whatever. And then we can update our tests to go and do that as well. So we can have those tests over the business logic of the functionality, and then that hardware interactions don't change. I press the button, here's what changes. At the same time, using AI, we can just go and kind of tell it to go and modify things for us so that we don't have to worry about it, don't have to do it ourselves. So it's pretty exciting. All right, well, thanks for watching. Don't forget, hop on down there in the fields down there, leave some comments. Hey, I don't know what I'm talking about. Hey, you're doing a great job, whatever you want. Drop some comments in there. Go to like and subscribe. They're in there somewhere too, somewhere down there. And yeah. Look forward to seeing you all next time.